Hello everyone. This is a pre-recorded presentation for MobileSoft 2020. We have submitted a tool and demo paper. The name of the paper is ReviewViz, assisting developers perform empirical study on energy consumption related reviews for mobile applications. The two authors are Muhammad Abdul Hadi, that is myself, and Dr. Fatemi Hendizani Fard. Let's move on to the problem statement. So the problem statement is actually threefold. The energy inefficiency is a major concern for the mobile application users, and they usually express their concerns by using app reviews or user feedbacks. That is why developers consistently analyze these reviews to identify the latest energy efficiency related issues. We developed a tool to empirically study and compare the different methods to automatically identify and extract these energy consumption specific reviews. We reported the accuracy F1 score and the runtime of these approaches, which included 60 traditional machine learning models along with relevant feature and feature combinations, and 30 DNN or deep neural network based models that use 6 different architecture along with 3 pre-trained word embeddings. After classifying the energy related reviews, we employed different topic modeling algorithms to identify topics that were actually causing the energy inefficiency in the first place for the application. But after developing the tool, we found no established mechanism through which the developers could track the progress within the community and identify the best practices. Moreover, there were no dedicated visualization tool that could help developers to quickly comprehend the outcomes of the implemented model feature combinations and methods used by the community. So we wanted to integrate those two problems and propose a solution using a visualization tool. Our developed web browser-based interactive visualization tool is a novel framework that makes it easier for the developers to traverse through the extensive result set generated by the text classification and the topic modeling algorithms by the community. So it also helps the developers to quickly comprehend the outcomes of implemented model feature combinations and algorithm used. The dynamic data structure that is being used by the tool actually stores the baseline results of discussed approaches, and it cumulatively updates itself whenever a new developer in the community performs any of the discussed procedure with a new dataset. This tool also offers developers choices to illustrate the result in a way that is convenient for any for actually specific user or respective user comprehension. So the tool attributes and the different aspects of the tool is discussed in this slide. So in the left hand side, we could see that the cumulative result, where every model and feature that has been tried out by any developers can be shown all together, but that is not very informative. So we let the user to choose a very specific model, and after choosing that model, we can show the chunk diagram. For this specific model, let's say naive bias, we can show that all the features that has been tried out for the naive bias and the accuracy and the F1 score for those features. We have actually 3 metrics. One is accuracy, another is F1 score, and another is runtime. And for the deep learning model accuracy for each DNN based architecture, we have actually used initially 3 pre-trained models. These are first text pre-trained word embedding, Glove pre-trained word embedding, and word2vec pre-trained word embedding, and we have reported the result in the visualization tool. This tool can also be used to incorporate any D3 visualization. So initially what we have started out with was a dendrogram tree that can be seen in the left hand side and a subtle packing diagram that can be seen in the right hand side. So we have chosen the dendrogram tree structure, which is actually a horizontal interactive tree, and it can store all the data in the root node. It has multiple nodes in multiple levels. So in the root node, we all have all the information, and upon selecting this root node, we can have different model exposed to the developers or to the users. And upon selecting a model, the model expands to all the feature selection nodes which actually was tried out with that specific model by the community. And upon selecting the feature, the model and feature combination can be exposed to the model and feature combination was selected to get the accuracy F1 score and the runtime, which is a cumulative and average accuracy are F1 score and the runtime for the whole community. And in the right hand side, we have actually used the topic modeling algorithms, and we wanted to know that which topic modeling techniques or topic mining techniques have been used. So here we have seen three different topic mining techniques. One is the regular conventional string matching method. The other one is OBTM, and the other one is AOLDA. So we can see that from AOLDA and OBTM, they have, or the developers have always mined or always extracted two different topics, and these smaller white circles actually represent different words that are being extracted from that topics, and the radius of those circles, those inner white circle, is actually dependent on the words contribution to that specific topic. And this is also an interactive diagram, and we can also zoom, drag, drop, etc. And we can actually explore in so many different ways that D3 visualization offers us. And to a point to be noted that we can also incorporate any other visualization tool that is preferred by the user. But for initial purpose, we have just included or incorporated these two most basic and most comprehensive diagram that could be found on the from the user side. So let's take a tour to the visualization tool, and we could easily go on to select and go to the link. Let's go to this link, and this is actually being run on a local computer by accessing a file, online file that incorporated or that accumulated all the results from different developers. So here we can see that this is the generated plots, and these are the chunk plots that can be actually selected for different models. And here we have seen the accuracy for the naive Bayes model and the runtime for the naive Bayes model. If we choose to select F1 score, this changes to F1 scores, and if we choose to select any other models, both F1 score and runtime changes and show the respective values and etc. And here on the horizontal x-axis we show which features were tried out, and in the vertical y-axis we show respectively runtime and F1 score if that was chosen in the first place. So this is a very interactive tool, and we can also show one DNN based model. Let's say select CNN, and we see that for the CNN, the fast text, the globe, and the words to wake are also shown. I have mentioned it before that these were the initial 3 pre-trained word embeddings that was used for the DNN based model. If more were used by the developers in the community, then more will show up here. Then let's go to the undivided plot or the whole plot. If someone chooses to go to the whole plot or the undivided plot, then they can actually go over there and the whole information can be represented here. So this is by default, our preference is ascending order. So these are all the model and feature combination that was tried out by the developers community, and in the horizontal x-axis. And if we choose to select the descending order, then the graph changes interactively. So if we choose no preference, then the x-axis will be sorted out by having the alphabetic order. So, and we can also choose to select F1 score, and that will show the F1 score in this bit. So what about the D3 visualization that we were talking about? The dendrogram visualization can be seen from here, where all the nodes were exposed, but that is not pretty informative. So we choose to collapse all the node, and we can expand any of the node. We can drag any of the node and collapse it on top of any other node that is there. So let's say we just want to explore a specific model. Let that be CNN was selected, and after that fast text, we can collapse fast text if we wanted, and we just show the word to vex, accuracy, F1 score, and runtime. The topic modeling result can also be shown here, where a rule-based string matching, this is the circle that represents the rule-based string matching method. This is the circle that represents OBTN. This is the circle that represents AOLDA. Developers can also choose to explore different topic modeling algorithm like BTM, OLDA, LDA, AOBTM, and etc. And that will automatically update the JSON file that was being used to update this D3 visualization and this Shiny application. So we can choose to actually incorporate that, but for the initial and for the presentation purpose, we chose to keep it simple. So let's explore the AOLDA part. So if we choose to AOLDA, we can see that this is the crash topic, and the topic were already determined by the algorithm. So this whole topic was named after crash, and this whole topic was named after charge. So let's explore the crash. So we can see that the top 5 contributing words were crash, slow, heat, temperature, energy. So we can also see that the slow and the heat has almost same contribution to the topic, and we can always go back and check out some other topics, and we can also check out some other mining techniques or topic modeling techniques that were used by the community. This is the end of slides, and thank you for being with us. Thank you.